Alright, loops. This tutorial will be about for loops, only for loops. If you don't know what that is, let me explain it to you. So, for loops is something that we define so that we can iterate over certain objects or certain code. So let's say you need to print something out for 5 times. Oh, by the way, I can give you a great example for that. You remember the Simpsons intro scene, right? Bart is writing down something that he was instructed to, I don't know, 50 times to fill up the board. Well, if he would be using for loops, he could just easily do that. So how? Because in for loops, you know exactly how many times you need to iterate, right? So you would define an index number in for loop, and you say, go over this, let's say, the range until it's finished. So in Python, you would literally define a range and say range from 1 to 13, and the for loop will go over that until it reaches 13. And when it reaches 13, it would break out of the loop. For example, in C, it would increase the number or the counter by 1 or the index number until it reaches the condition where it will be not true. So in Matlab, we have something, again, index, but we go over matrices. So for example, I'm going to write something really simple and we're going to go over a matrix. So let's say for index, actually index is a really ugly word. I'm going to use K, and the reason why I'm not using I or J is this. I is square root negative 1, and it's the same thing for J, and the reason why we use J for square root negative 1 is that in electrical engineering we have current for I, so we cannot use I, so we use J. So both of those terms are defined for square root negative 1, and we don't want to use that keyword, so we use K. So for K is equal to, so look at it carefully, this is our range, 1, 3, and 7. These are arbitrary numbers, they're just made up in my mind. You press enter and you define a condition. So notice, K will be equal to 1 at the first iteration. In the second iteration, it's going to be equal to 3 here. On the third iteration, it's going to be equal to 7. Alright, this is very important. And it's going to iterate over this thing for 3 times, exactly 3 times. So let's write our condition. Say display or something, a new function, right? fprintf. Okay, so let's say number, and you enter %d. %d means it's an integer. You close single quotes and a comma, and you type the numbers variable. The variable. And before doing that, I want you to notice something. When we do that, it's going to write next to each other, so it's going to look ugly, but I want you to see it. So press enter, and all right, you see it's ugly. So how can we change it? So copy and paste the whole thing again. I know it's stupid, but you press slash and it means new line. Okay, so press enter, you see number 1, number 3, number 7 printed in a really good neat form. Alright, that's great. So we can even do better examples, right? Because here we knew the exact number of iterations, 3. Well, we're all going to know about that, but we can make even better examples of that. So let's say 4 and K is equal to 1 to 100. So I know there is going to be a 100 iterations, but the thing is, we don't have to type exactly like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm not going to count all the numbers here. But we know how many iterations it's going to take. So let's say this time you do something different. This time, what can you do about it? Let's say A is equal to 10, all right? And I put the semicolon so that it won't print it out, and say A is equal to K plus A. It's a really interesting form, right? So we're going to see what's going to happen, and we press enter. Well, fprintf, we're going, actually I can copy this out, okay? Fprintf, instead of K, we're going to write A, and everything else is the same, and so you see, well, why? Like, You might ask, but it was 10, so in each iteration, it's going to be 11, so 11 added to 2, then it's going to be 14, so why is it increasing in a way that's 1 by 1, right? Well, look at this. This is really important. Here, when we iterate over this, a is equal to 10. Since k is equal to 1, a is equal to 11. That's correct, right? It starts again. A is now equal to 10 again. So it does the same thing over and over again. So it's increasing by only 1, all right? This is really important. So let me copy that and change the code to this form. So watch me doing that. Okay, this is our code. Let's say we do different. We do something different. We make the step size 5, right? So what's going to happen is this. A is going to be 11, then 16, and it's going to go up to, I don't know, 96 maybe. 106. All right, this is our result. So you see you can play with it and define your own thing. So I think I can do one more example on that, and it's going to be on increasing the result of a number. So let's say sum is equal to, I don't know, 0, all right? Then we copy paste our thing. We say, we don't define this any longer because it's causing a problem that we don't want. And let's say sum is equal to k plus sum. All right, so the sum is going to be increasing by the number of itself. So it's going to be a really big number when we reach the end. So you see, oh my God, there's a problem here. Let me see what happened here. That's something that I didn't expect. So sum is equal to 0, 0 plus 1 is equal to 0, 1. I don't really know what happened here. I'm sorry. I don't know why I made this mistake, but look, it is A that we're, so okay, that's really funny. So let's paste sum. All right, I'm sorry. I copy pasted the wrong thing. Copy, paste, and type sum. All right, oh my God, look at this number. And do you know why it starts from 50,000? Sorry, 5,000? It's because we've run this loop before and it reached the value that was equal to 5,050, right? So that's something really interesting. So you can play with it anytime you want, but make sure that you're not doing something like an infinite loop. It's really dangerous. I've tried it before. I don't know how to stop it, but it might be Control C. It was Control C in Python, but it's not the same thing here. All right. So one last thing that I want to talk about is nested loops. It is something really interesting. So let's say for k goes from 1 to 10, right? All right. Then we define another loop for m goes from 1 to 5. You define a condition here, disp, let's say m for, and another end, because we have finished two different ends, two different for loops. So what's going to happen is this. Before we run it, let me tell you what happens. So first for loop starts running, okay? Only the first iteration. First iteration enters here. And only in the first iteration, the second for loop finishes its sequence, finishes all the iteration that's going to take. So it will run 5 times in the first iteration of the first loop. In the second one, it's going to run this thing 5 times again. So the number of iterations that's going to happen in total is going to be equal to 5 here, 10 here, 50, right? Well, if you add up the iterations that's happening in the top for loop, it's going to be 60. So let's do that. Oh my God, lots of numbers. Look at it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it happens 10 times because we run the for loop 10 times. You can, well, how could this thing be useful? Okay. When I was working with C and C++, when you're like dealing with multidimensional arrays, more for loops like nested for loops would be really useful because you would want to get inside of an array and work with different values. So you would, let's say, do something for one row, but each column inside of that one row, and you do that for the second row, third row, and fourth row. When you're doing that, you have to do all the operation for all the columns here. So that's why it could be useful. All right, I think that's it. I'll see you in the while loops tutorial. Thank you for watching.